Do you ever wonder where some of the units come from? Meters per second. This is the same way, or it represents the same thing as this, which represents the same thing as this. And where does that come from? If you consider the button on your calculator, which probably says x to the minus 1, that's the same as 1 over x. So from what we've got down here, this is from this section here, we've got meters times 1 over second. That's the same from, remember, from that with our notation of x to the negative 1 is 1 over x, we've got meters times seconds to the negative 1, and that's where we get the ms to the minus 1 from. Cool? I think that's pretty cool. Let's have a look at something just a wee bit more complex. If we consider the acceleration, meters per second squared, that's the same as meters times 1 over second squared, which the linking thing between there is meters per second squared. Each of these three things is exactly the same as the other. And this goes into some a deeper notational rule where the 1 over s squared is the same as same as s to the minus 2. So the deeper notational rule, if we were going to make a general case rule for this, it would be 1 over any number x to the power of n is equal to x to the negative n. So there's a very mathematical lesson, but you can see how it applies to units with meters per second and with meters per second squared. One final example. Let's consider a colour I haven't used before. Let's consider, move all of that up and out of the way too, torque. Now remember the equation, torque equals force times distance. The units for torque are the units for force times the units for distance. So if we do a units equation, okay, my notation for equation short there, units equation, we would look at the units for torque are newtons per meter. Sorry, newton meters. What am I talking about? Spring constant is newtons per meter. Torque is force times distance. Newton meters and torque is the force unit newtons times the distance unit meters. Newtons meters. So I actually did want to do the spring constant one. So let's just shift this across and do the spring constant one over here. Spring constant comes from this formula, F equals kx. It's sometimes written as minus kx because the negative indicates the direction of the restoring force. When you stretch a spring, the negative shows the force is trying to make the spring go back to normal. But anyway, the rearranging this to find the spring constant units, k is k. We'll ignore the negative for now. K equals F over x. So if we're looking at the units for that, we've got, so let's just do a bit of a line to separate those two. The units for that is, the units for spring constant is newtons per meter, and we can see from the equation it's force, which is newtons, over x, which is distance measurement, the distance you're extending the spring in meters. And again, it's that same thing. You've got newtons times by 1 over m, and 1 over m is equal to m to the minus 1. Going way back to the start. Hopefully that's given you a bit better understanding of the underworkings of units.